So another thing we can do is if we talk about two triangles, we also have what's called similar. So similar kind of means they look alike, but they're not necessarily the same size. So two triangles are said to be similar if they have the same shape, but not necessarily the same size. So what this kind of means is the corresponding angles are equal. And what's neat here is the corresponding sides are in the same ratio, or they're said to be proportional. So this is all fancy for this fraction stuff. So proportional kind of has this numerator denominator stuff. So a ratio is comparing two numbers by division, and comparing two numbers by division is actually, as we mentioned earlier, is a looks like it can be written as a fraction. So we have these different little ways to say that two triangles are similar. There's what's called the AA theorem. If two corresponding angles are equal, then the two triangles are going to be equal. Because remember, if two angles are equal, then the third angle's got to be equal as well. So remember, to be similar, the corresponding angles have to be equal. The next piece then, what happens is the corresponding sides will become what we call proportional, similar. The side similarity, if the corresponding sides of the two triangles are in the same proportion, then the triangles are said to be similar. So if we do the ratios of the corresponding sides, if they create the same exact ratios, then the two triangles are said to be similar. So we have a side angle side similarity. So two corresponding sides are equal and the included angle is equal. I'm sorry. The two corresponding sides, the ratios, I keep missing that word. If the ratios of the two corresponding sides are equal and the included angle is equal, the two triangles are similar. Notice that, congruence and means, a little bit different than proportions and ratios. So watch out there. If the two ratios, so we're comparing the ratios of the two sides. So we'll see that in some examples here. So let's actually put some algebra into the problem. So this question here says find all the unknown angles in the pair of similar triangles. Note the triangles are not drawn to scale. So notice how they're saying that these two triangles are similar. If we say the two triangles are similar, that means corresponding angles must be equal. So let's start with angle triangle. Let's look at this. Let's go from B to C to A. So they're saying like triangle BCA is going to be similar. And this is a symbol for similar. It's without the equal sign. So triangle BCA is going to be similar. Now, if I do similar, I got to go in the same path. So notice how angle B corresponds to angle M. So when I do this triangle over here, I have to go triangle M and go to P and go to N. I have to go in the exact same order. So triangle BCA would be similar to triangle MPN. So one of the things is though is if these triangles are similar, then corresponding angles are equal. So angle B would have to equal angle M. So angle M is 81 degrees. Angle C is 36, so angle P's got to be 36 degrees. So what's missing is we need to know the measure of angle A and we need to know the measure of angle N. Now remember, the sum of the three angles in a triangle have to have 180 degrees. So we had that definition earlier. So that means that the measure of angle B plus the measure of angle C plus the measure of angle A has to equal 180 degrees. And I'm just going to write 180 there. We know angle B is 81 and angle C is 36. We don't know what angle A is, but we do know together they add up to 180 degrees. So that's how we actually create an equation. So in equation, we have our strategies. So notice how we can add 81 to the 36. So 81 and 36. Again, you could use a calculator here, but I think I can get that math. 117. So 117 plus the measure of angle A must equal 180 degrees. Now to find the measure of angle A, I got to get this by itself, treat this like a variable. It's unknown. So I need to move the number to the other side. So to move the number to the other side, I have to subtract 117 degrees. Whoops, I don't like that. So we're going to subtract 117 here, but we have to subtract 117 over here. So in doing so, we're going to have a new equation that says the measure of angle A is going to equal, well, what's 180 take away 117? Or what can you add to 117 to get 180? I'm kind of a little fuzzy on that one, so I'm just going to do a little bit of borrowing. 10 minus 7 would be 3. 7 minus 1 would be 6. Does 63 plus 117 get me back to 180? Yeah, that does. So the measure of angle A would be 63 degrees. So when I find the missing angles, notice that if angle A is 63 degrees, then measure the angle N, since it corresponds to angle A, it has to also be 63 degrees because, of course, if the triangles are similar, then corresponding angles are equal. So since they said that triangles are similar, we know angle B is equal to angle M, C is equal to angle P, and A has to be equal to angle N. So the only thing we have to know is, wait a minute, they gave us two angles of a triangle. Well, I can find the third angle of a triangle because all three angles of a triangle have to always equal 180 degrees. So we have enough math there, enough information to solve the problem. So let's look at this one. So find all the unknown measures in the pair of similar triangles. Note the triangles are not drawn to scale. Okay. So let's how again they say the triangles are similar. So to me, if I call this point A, this point B, this point C, it looks like these sides are going to be corresponding. So I'm going to have, we'll call this X and this Y and this Z. So it looks like they're orientated the same way. So what I pick up on is I could say triangle ABC is similar to triangle XYZ if I want to add some information to help me understand the problem. So we want to find the unknown measures. So it looks like based on the drawings, they want us to find A and they want us to find B. Well, since the triangles are similar, that means, and if I'm going to go from big to small, that means AB is in relationship with XY. So AB over XY, that ratio should be the same thing as BC over YZ. So BC should be in ratio with YZ since they're similar. And this should also equal the same ratio as AC over XC. So these three ratios are equal. So what we can do is create what we call a proportion. So a proportion is a ratio equal to a ratio. So notice that we have 18 to 9. They're in ratio. So one thing you can kind of pick up on is what's the relationship between a 9 and an 18? Well, it looks like 9 is half of 18. So if this is going to be if 9 is half of 18, then that means A's got to be half of 18 as well. So A would have to equal 9. Now I could set up a proportion. So 18 over 9, so notice how AB is in proportion with XY. Notice that BC would be in proportion with YZ. So I could write this other side as 18 over A. So that's like BC over YZ. Now, in proportions, you are allowed to cross multiply. So you could say, hey, 18 times A must equal 18 times 9, must equal 18 times 9. Now, I don't have a calculator to do 18 times 9, so, but I do know that to solve an equation, I can get this A by itself by dividing each side by 18. But notice how this actually helped me by not trying to go any further because I get the coefficient of A is now 1, but notice how these 18s will actually divide out and A would equal then 9. Because remember, in division, if you have the same number on the top and bottom, it will divide itself out and turn to a 1, and 1 times 9 would be then just 9. Okay, so we got that. Now, notice how 19 would have to be half of, or B should be half of 19. Well, what's half of 19? Well, I think half of 19 would be 9.5 because 9.5 plus 9.5 is 19. Now, what I could do is set up a proportion. I could say, hey, we know this 18 over 9, that's given to us, that ratio. So these corresponding sides were known. But notice how this B would correspond to the 19. And since I went from big to small, 18 to 9, I got to go 19 to B. So 19 over B. So what I can do again is, since we have a proportion, we can cross multiply. So 18 times B would equal 18. I'm sorry, let me try that again. Oh, hang on here. Got to cross multiply. So if I cross multiply, 18 times B should equal 9 times 18. I'm sorry, 9 times 19. Cross multiply. So 9 times 19 should equal 18 times B. Now, to do some algebra, all I got to do is get B by itself. So if I divide this by 18, I should be able to divide this side by 18. So if I do that, notice that the 18s divide out over here, but notice how the 9 and the 18 have a common factor. I can divide a 9 out here, and how many 9s go in 18 would be 2. 9 goes into 18 twice. So notice how I could actually reduce that down to then B would equal 19 over 2. So that would be an improper fraction, but we also could type in 19 divided by 2 into a calculator, and we would get 9.5. So, because 9.5 plus 9.5 would be 19. So we can use our own critical thinking skills, but notice how we also could be using some algebra here. So there's A over here using algebra, and here's algebra over here to find B. But notice how I also can just look at it and say, hey, wait a minute, the corresponding sides have to be in proportion. So if this is 18 to 9, then this also has to be 18 to 9. That's a little trickier though, because that's 19. But notice how we do see that, hey, 9 is half of 18. So what's this got to be? Well, it's got to be half of 19. Well, that's what we did. Half of 19 means to divide by 2. That would give us this 9.5. So we found the unknown angle. It looks like it says find all unknown angle measures in this as well. I don't think it's asking for angles here. I think it's asking for missing sides. So that looks like a misprint. So we'll look back at that because we don't know anything about the angles per se. So this must be the unknown side measures because A and B are sides. So let me look into that, but I think that was a typo there in that problem. We're looking for the unknown side measures. Okay, so next thing we get into is the Pythagorean theorem. So we'll pause here.